So let's summarize and highlight what is unique and special at ELPROMA synchronization product. There are several advantages of ELPROMA comparing to competitive product. We can split them defining the value-add functionality into the two groups, the one related to antenna and the one related to time server itself. Let's focus on the antenna first. The ELPROMA antenna is a very special one. It is called the smart antenna. It is smart because it is including the built-in GNSS receiver and additional electronics supporting communication down to time server. The smart antenna can be equipped with various of replaceable GNSS receiver boards, each equipped with a different chipset. Each chipset comes from a different vendor. The Industry 4.0 is requiring well understanding of geopolitics. The world's biggest economies of China, United States of America, European Union, Russia and India prefers to exclusively use their own state satellite system for Industry 4.0 synchronization. At the Industry 4.0, the rules are short, constant and clear. The US economy needs to be dependent exclusively on a GPS only. The China economy will prefer dependency on China Beidou. Russian economy will accept dependence on GLONASS. India will focus on its new satellite system called IRNSS. Finally, the European Union will follow the time supported from Galileo satellite system. All other countries need to make a wise decision which of existing GNSS systems they want to be dependent on. Here probably the best choice will mostly point the full GNSS constellation. Now let's talk a little bit about replaceable GNSS receivers the NTS-smart-antenna can be equipped with. ELPROMA offers only the best approved GNSS receivers coming from world's most famous vendors including the Swiss-made u-blox, US Trimble, Japanese Furuno, European Septentrio, Russian NVS. But our portfolio carries much more receivers to select. ELPROMA customers can choose suitable GNSS chipset following the price criteria or a frequency criteria beginning from single band L1 frequency via dual L1, L2 or L1, L5 frequencies or even up to triple band L1, L2, L5 GNSS receivers. Of course, the single frequency L1 band receivers are most inexpensive one and they mostly are limited to very standard accuracy of stability of synchronization. The dual and triple frequency receivers improve robustness of synchronization, especially if the weather conditions are not good, but unfortunately they are more expensive too. Setting customer strategy is important when deploying synchronization at critical infrastructure or at large enterprises. Here, ELPROMA experts are always ready to assist giving right professional advices. The replaceable GNSS receiver modules are also very helpful when finding the unexpected firmware bugs inside the receiver. Normally this takes weeks or even months before a new firmware patch, the one covering the bug, will be released by chip provider. But here a simple replacing of GNSS module to another one, the one that bases on a different chipset, seems to be fast and very reliable plan B. Today, each of time server manufacturers still needs to consider a risk of instability related to numeric overflows inside the GNSS chips, especially when supporting the UTC leap second or handling problems like GPS weak number rollover, but also the errors related to algorithms when switching between specific satellite constellation GPS, Galileo, Beidou or GLONASS. Here, a locally done replacement of GNSS module at NTS-smart-antenna plays the important role to ensure continuum of operation at customer premise. Here our competitor fails, and they need to organize a service call. After months of waiting, the lucky customers are getting the new firmware patch to download. Unlucky customers needs to send back to factory the competitive time server product. The NTS-smart-antenna also improves stability and robustness. One of the unique functionalities is the possibility of simultaneous use two NTS-smart antennas connected to a single ELPROMA time server. It enables a real physical redundancy of GNSS receivers, but it also lets use a custom configuration where each of two receivers is focused on the different satellite system. Let's consider the first antenna to be configured to receive the GPS only and the second one to GLONASS. Does it make sense to you? Even the enterprise can be obligated by the law to follow, let's say, the GPS only. In some cases, it makes sense to trace the GLONASS and other satellite systems too. Tracing GLONASS does not necessarily mean you have to use it as a reference for synchronization, but it is still useful to know or compare both GPS and GLONASS, each coming from a different receiver, each exclusively set to operate with GPS or GLONASS. Such duality and redundancy ensure everything is stable and there is a minimum risk of time manipulations, including satellite spoofing or a delay McCuning attack. Here the GPS and GLONASS are only the examples, and therefore we highlight that any of them can be replaced in a real application by Beidou, IRNSS or Galileo. When considering the cybersecurity, it is important to highlight that ELPROMA standard product already includes the basic jamming and spoofing protection. Using two redundant smart antennas located a couple of 100 meters from each other provides the geographical risk diversification. If the one NTS smart antenna is spoofed or jammed, the second can survive, keeping a full access to original satellite radio signals. But the standard ELPROMA smart antenna can be also equipped with the GNSS receivers that automatically recognize false, not original or reflected satellite information. Once the NTS smart antenna detects jamming or spoofing attack, it sends a special alarm message down to ELPROMA time server. Such alarm enables a holdover operation of time server that automatically switch to internal high-performance oscillator clocks. When operating in holdover oscillator mode, the time server is not using NTS smart antenna. Once the jamming or spoofing attack is ended, the end of attack message is sent down to time server to recover normal GNSS operation. The NTS smart antenna can be also equipped with advanced active anti-jamming and anti-spoofing filters. The active filters are automatically recognizing source of fake signals and they do filter them, staying transparent to original satellite signals. ELPROMA smart antenna can be also equipped with the multipath mitigation subsystem. It recognizes reflected from building satellite signals and refusing delayed phantom data from it. Finally, the smart antenna is also including auto-sensing and adopting auto-gain system. It let operate ELPROMA product in tough environments where there are bad weather conditions and electromagnetic interferences. The signal conversion to electric serial communication makes ELPROMA smart antenna easy to maintain during installation. The maximum connectivity length is up to 1 kilometer and solution is not requiring additional signal amplifiers. Cables can be cut or extended using standard Ethernet unshielded twisted pair category 5 or above cable. Altogether, this makes ELPROMA smart antenna a very unique and robust synchronization component. This is the last slide of this presentation. It shows a very little and partial list of customers who put a trust on ELPROMA product, choosing our time server last years.